conference today. So my name is Putri Fitriati. I will be your moderator for this keynote uh, for this keynote session 3. And I'm pleased to welcome all of you here to the International Conference on Science in Engineering and Technology for the second day. So as stated in a schedule, we will have a great keynote speaker here. So Professor Shen Jiangshen, whom will be given a speech about his research in the field of urban simulation from 8:30 to 9:15. So before we starting, I will read the curriculum vitae for Professor Shen. So he is graduated from Tsinghua University for his bachelor degree and also master, and from Hiroshima University for doctoral degrees. Now he currently as a lecturer, as a professor in Kanazawa University in College of Science and Technology. So his research field is urban planning, articulate planning, particularly spatial analysis, GIS, and urban simulation. So this is the academic society is International Community and Spatial Planning and Sustainable Development, City Planning Institute of Japan. Professor Shen is also an editor-in-chief of ERSPSD International. So this journal, international journal, ranked key 2 in Semago. And also, we can see if you have an interest to submit your manuscript or to be a reviewer in ERSPSD International, maybe Professor Shen will welcome you. Here is the website. And Professor Shen have so many publications, and I don't have to mention it one by one. You can search it in Google Scholar, also Publish, and so many websites. Professor Shen also published several books with Springer. Here is the book series. And that's not last but not least, maybe the brief introduction about the Professor Shen. So for not wasting too much time, I will welcome the honorable keynote speaker, Professor Shen. Please, Professor Shen.
Thank you very much for your invitation. And firstly, I'd like to share my screen firstly. Is that possible now?
Yes.
Okay. Thank you very much for inviting me to be the keynote speaker in this international conference. And I remember last year, I also joined another international conference in Palu.
Yes. Yes.
And thank you for your invitation this time too. And also I like to show my special thanks to your wire lecturer, Amma, and the Dean of Andy, and other colleagues for organizing this conference. I think the moderator, Pudri, and one of the section chairmen, Rifai, also have studied for 3 years for your PhD study in Kanazawa University. So I'm also very happy to renew with you in this international conference. And I think last time I presented a talk, including some work cooperated with RIFI in Canada University. So today I make a presentation that quite relate with the work of Puteri.
Thank
so probably you can understand if we have get some questions. I think you can answer questions for me. Okay. Thank you very much. So I think I have probably 40 minutes for this presentation. So
yes.
I just start this presentation. And can you see my screen?
Yes.
Yes.
You can see your screen, Professor.
So my topic this time is visualization of building form regulation and optimal solar design of smart house using some planning support system for energy management system. And the work I have done is supported by several GSPS program. I listed in the below of the title, and so totally I almost took 10 years for support to do this kind of research. And for this presentation, I think there's several keywords is the visualization of building form regulation, and another part is the solar design, and another keyword is a smart house. So this topic is related to the smart city construction in Japan. And my consideration for doing my research work is the flow I show in this slide. We have 4 steps for doing this research work. One first step, we're checking the building regulation for building form in Japan. So the first step is to visualize the building form, and we consider this is useful for consider how to locate the solar panel in the rooftop. So the first step is visualizing the building form for solar panel design. And the second one actually is the work done by Dr. Puteri. Is optimal design for solar panel. So all the work, the 3 points here, actually is done by Dr. Puteri. And probably Dr. Puteri can make more implementation for me. So we consider the position of the solar panel for energy generation. And we also consider the opening part, the size, and the shape of the buildings for energy efficiency. And then to visualize the building form for the solar panel is the second part. So we first we consider the building regulations for locate the solar panel. And then we move to the second part to consider the solar panel design of solar panel resource. And to the 3 part, we consider the energy consumption based on the household behavior. Because the Japanese governments like to launch zero energy policies for the new constructions in the whole countries. And from 2018, all the new building, the standard of the new building should be zero energy. So 50% new construction should follow the zero energy building standards. So the only technologies cannot be solve all the problems. So the energy consumption based on the household behavior is also a very important part of these policies. So in the 3 steps, we consider how to improve the household behavior to reach the goal, the energy consumption, the zero energy consumption. But it's not really mean the consumption is zero, it's mean the balance between the electricity facilities and consuming the energy in house and buildings. It means people can sell the generated and electricity power to the facilities. When the amount of the generated energy power by themselves is not enough, they can buy the power from the facilities. So the balance for buying and selling can be zero. That means the zero energy in Japan. And after these three steps, so you consider how to making the planning at the level in the city and communities, and how to invest the solar panel, and how to consider the total system for energy consumption, the energy management system. So this 4 parts of my presentation. And in the middle, we show pictures here. It's more focused on the zero energy house. It's a concept graph of the figures of the Japanese smart house. My research is more focused on the house and smart house. So I think this topic is related to the concept of a smart city in Japan. These figures, this slide show a comparison between the Japan, Europe countries, and the North Americans about the smart city concept. So I think some of you know the concept of Japanese smart city well, and I'd like to introduce once again here. You can see in Japan, the smart city is divided into the 5 levels. And the first level is the real estate development. So it's more focused on the construction industry. So before so beyond the real estate development is another layers. We call it the basic infrastructures. It's very much civil engineering, civil infrastructures, urban infrastructures for the urban development. And after these 2 levels, we start to consider what is smart in the urban areas. So you can see the smart infrastructure, like the internet, information communication technology, the facilities can be constructed on based on the construction of basic infrastructures. And then we can use the big data to provide the live service, to provide the smart service for the human, for the residents in the cities. So we build the smart facilities firstly, and use the big data and the ICT for provide live service in Japan. And then finally, the people can have the big data, have the smart service, and have the smart infrastructures. They can build a new lifestyle, and then you have the new cultures, probably the new art form in Japan. So this is the total concept of the smart city in Japan. It's more can relate to the building and the planning. It's more related to the construction industries. My field is architecture and planning. So the concept of the smart city in Japan is more related to my fields. But in the European and the North American, you can see there are different considerations with Japan. They only focus on the construction industry. They can have more technologies. They can combine each other for create the smart living, smart government, economic, and environment, and others. And the human behavior for smart people and mobility also important topic in the smart city in European countries. So there's one more things discussion I think is possible for me to introduce one more time about the smart city and smart house. And this big data here. So you can see smart city, including the ICT, information communication technologies, and also including the IoT, Internet of Things, that can form smart infrastructures. And then we can build a new styles building, and which can provide the smart lifestyle. We can have a smart house. And the important thing is the big data. The big data can be used for providing the smart service in urban areas. So this is in Japan. It means the service is smart, and the infrastructure should be smart. Okay, this is concept in Japan. And this is the four pictures is prepared by Minister of the Japanese government. This one is about how to use the big data, and this one, I mean, in the middle side of the right side is to construct the smart infrastructures, and above the pictures in the right side mean how to use the big data collected from the smart infrastructures and for urban management. And in the left side, in the below, there's a total concept of the smart building and smart house in Japan. It's more focused on the energy management system. In the above figures in the left side, this means the smart house. We have a system we call it the HEMS, the house energy management system. So most of my research focus on these figures. I mean these figures. I mean these figures. This mean the house energy management system. So this is the concept of the. I'm sorry, it's edited in Chinese. This means this is the concept of the HEMS, the smart house. You can see their appearance, which can be controlled by intelligent control system, and also in Japan, the people more focus, the engineering more focus on the HEMS system, house energy management system, and all the data can be connected from this kind of appearance to the urban centers. And also, these urban centers can combine with the smart service for the disaster, for the commercial and traffic and energy facilities and medical service. So the individual house, the data from the individual house and the data from the urban facilities, I mean the infrastructures and public facilities can combine into urban data centers. So this is the concept of the smart house. And my research this time I present today is more focused smart house in the later part. So I think I take a long time for explain backgrounds. I think it's necessary. So now I try to introduce my research from the four step I introduced in the beginning of this presentation. Last visualizing the building form for solar panel design is based on the planning regulation, building regulation in Japan. And the second is the optimal design for the solar panel. So all this work has been done by Dr. Puteris. I think probably can introduce more interesting than me. And the third part is energy consumption based on the house behavior. So it's for reach the goal of zero energy buildings in Japan. So the part of house hold behavior is very important to reach this goal. And finally, we'll consider how to manage the energy system at the level of a community and cities. But it's only from the view of planning and design. And so firstly, I'd like to introduce how to visualize in the building form for the solar panel design. But this part is only focused on how to visualize the building form. Anyway, this is the concept of the home energy management system. this is the appearance the system, smart device using in a house for the goal of zero energy house in Japan. So people can generate the energy powers, and they can sell the energy power to the electricity facility in the city. And also, when the power generated by the solar panel is not enough, they can buy the electricity powers from the facilities. So the balance, if the balance is zero, that means the household can reach the goal, zero energy house. So this is the concept of the smart house and the goal of the home management system in Japan. So we visualize the building form that we consider for design the solar panel in the roof or in the wall. So in the building, in other words, and so we use the GIS system to simulate the building form. So I think probably you're not familiar with the Japanese planning regulation. It's very complicated, and there's many regulations about not only control the FAR, floor area ratio, and also control the building form. And that's where this part it's quite difficult to show all the regulations, but they have oblique line from the front row from the adjacent loads, so to define to control the building form. So we have a build system for this. I think this one is more understandable for understanding what kind of work we've done. So in the right side, we design all the parameters from the planning regulation in Japan. So a lot of parameters. And this is green shape is mean the regulation control the building form. So you can understand that rooftops will be controlled by the building by the regulation from the front row and from the adjacent row. And so the building form is defined by planning regulation. But most of designers don't like such kind of planning regulations, but it's just a control way to use the control measures to define the planning, the building form. And so we also do in other words, to checking if the building is illegal, no suitable for, no follow the planning regulations. We can see the system can check automatically to understand which one, which building is no follow the planning regulation. So this, I think, probably is interesting to you. And then we can output all the checking result and understand which one is illegal, which one is legal. So this kind of where we're checking the building form. The purpose for checking the building form actually is to try to locate the solar panel in the building. So there's a regulation for limited the ratio of locate the solar panels. So we calculated the electricity's powers, how can be generated in the rooftop. You can see the red bar is the amount of the generated of energy powers in each month. And finally, we can see how much the energy power can be generated by the solar panel in the building within 1 year. And these figures show the building regulation to regulate the urban shape. So that's the first work we have done to consider how to locate the solar panel and how much amount we can locate the solar panel. And the second part is focused on the solar panel itself. So this work is being done by Dr. Pudri. Is the framework of the Dr. Pudri's the PhD dissertation. Yeah, divide to the passive sonar design and active sonar design. So in the active part, we consider the PV system itself, and in the passive sonar design, we consider the opening part of the building itself. So this part, the passive sonar design more focused on how to design the buildings, and active sonar design we consider how to use the solar panel. I think the Dr. Pudri know more than me. Yeah. So this is the some new attempts we have done in this work. As you can see, we analyze the potential of the photovoltaic installation based on the available envelope services to satisfy the future energy demand. So this is climate situation in Indonesia, and we consider not only the rooftop, we also consider how to install the solar panel in the building envelope. It is actually in Japan, in the module areas, I mean, in the very famous areas, in the Kashiwanaha areas, the designer apparently also install solar photovoltaic in the building envelope, and also it's very effective to generate electricity powers. So this work has been done by Dr. Purdy to simulate how much amount we can get from the solar in the rooftop or in the building envelope. So you can see this we simulate each month, and in the right side we simulate each days. This I think that's average situation of the simulation. So this work is consider the orientation of the buildings, and also consider the duration of the solar panel. We also consider the interaction between the neighbors and the effect from the neighbor buildings. Then this one is considered where to locate the install the solar panel. And the second, we consider how to design a building for support the energy savings work. So this work, I think, is a simulated work, but done by Pudri in Indonesia. The case study is in Indonesia, so you can see the sample 1, 2, 3 is a building in Indonesia. So we consider the height of the building, the shape of the window, the height of the window, and the areas of the window. It's an open size for of the buildings, and we simulated the daylighting, and when we need to open the lights or when we can switch off the lights for energy savings. I think the project do this work very carefully, and you can see it's a simulated work. This means the distribution of the daylighting, so you can see where I mean the place with the opening, and will have a different light distribution amount. So in a different shape of the opening, I mean the window, and a different layout of window, we have the different daylighting strategies for the buildings. So this can be used for energy saving. And this is a simulation work done by Pudri also. So you can see this in this simulation. I'm sorry, this it's not available. It's okay. No, work. The number shown here is the daylighting. The amount of the lux of daylighting is simulated based on the opening size of the buildings. and then we can also consider layout of the buildings, and so we can design how to consider the layout of the lighting for energy saving. And also, if we use the automatic switch off and switch on system, you're more available for energy saving in this role. Also, I think Putari do a lot of jobs for consider the roof design of the solar panel too, and they consider different types of the solar panel, the different materials, and also we consider different designs, and also we consider how to consider roof design for energy savings. That's very important for the energy energy saving, and also very important for the indoor environment. I think Putari have a very good consideration. We like to consider the roof design as 2 layers, and so the indoor environment, the cost of the building can be low, and the indoor environment can be improved, like for no, how to say, the temperature distribution changes, more comfortable for human. So I don't have enough time. I think this can be, I think Dr. Putri can explain more carefully and more interesting than me. So in the third part, we have to consider the household behavior for saving energies for reaching the goal of the energy saving. In this part, we simulated human behavior. So we're based on the big data and the multi-agent system to simulate the energy consumption. This is a table. I'm sorry, it's edited in Japanese. It shows all the human behavior in the old days. So all the behavior in outside or inside the room. And this is the investigation. It's a formal investigation done by NHK. Is to investigate each 15 minutes, how the people will do in each 15 minutes. So we call it the 15 minutes distance life investigation. So it's quite useful for simulating how people use appearance and how much energy they will consume by the distance. Then you can see these figures for the eating. You can see how many people's, the distribution or the number of the eating time in one day. So you can see there's 3 pictures: the lunch, morning, breakfast, lunch, and dinner. So, and also they have the sleeping time, then eating time. So it's very useful for simulating the energy consumption. Because we can figure out how many times in which for each appearance, and how the appearance consumed energy. So you understand the total amount of energy consumption in each building. And also, based on the behavior, 15 minutes behavior investigation done by NHK, we know that how their lifestyles. Basically, there are 4 patterns in Japan. This is 44 hours, and it's mean 1 means the stay in home, and 0 means the outside home. So when people in the house, you consume energies. There's 4 lifestyles here, I think, because the time limited, I don't like to explain carefully. They like how husband and wife are working together. So when the working time from the morning 8 o'clock to the 18 o'clock, nobody living in the house. So it's at 0. So energy consumption will be low during this time. But when they're off, when they're living in the house from before the 8 o'clock a.m. and after the 16, the 18, and so they stay in the house. So they consume energy. So there's the four types for lifestyle. So they stay different types in house, and there's a different style for energy consumption. So this is the one type of the behavior in each 50 minutes. This is a behavior. I'm sorry, it's in Japanese. This is a behavior. It's a time of each 50 minutes. And then we ask what kind of appearance they use and how much energy they consume based on the behaviors. And this is the different lifestyle and the energy consumption in buildings. There's four types, A, B, C, D, the four types. We show the different seasons in the different types and different seasons in the one day. We show the distribution of the energy consumption. And then we have a lot of big data we collect from the real side, and then we can check in which house is belong to which kind of lifestyle. And then we can predict the energy consumption in the future 1 month, 3 months, or 1 year based on the different seasons. Right? So we can understand how we will predict the energy consumption of each house. And this is kind of we can define their lifestyle, and it will then predict the energy consumption. So this is the work done by the big data, the energy consumption per 30 seconds. This is the ID 25, this means the sample house, number 24. And this is simulation system for simulation in a community. So you can see there's a lot of buildings here, and they have a different lifestyle. And we simulate their energy consumption in each buildings. And these figures show one house. So we can summarize how much these communities will consume the energy totally. So this is simulated result too. This interesting results mean we can consider the characteristic of the Ishikawa, the Kanazawa areas, and to make more correct the simulation result for energy consumption. So this is the I already introduced the three part, how we consider the smart house, consider how to use the solar panel. First, we visualize the building form for solar panel design. And second, we consider how to install the solar panel, and also consider the opening design of the buildings. And then we simulate energy consumption based on household behavior. And so then we understand how the buildings and the people will consume the energy consumption. And then we try to use for the planning practice. This is we consider the HAMS in the three levels. Is the house level and in the difference in the neighborhood levels. So this is some kind of consider for the community design. So we have the house unit is one house, and there are a lot of house there. And in house we have solar panel, and then the house will use the distributed energy storages. And in the neighborhood, totally we will how to save we have a storage, how to save the buildings and how to interaction with the facility, electricity facility in the city. And this is, we also consider how to invest in, how to consider the investment plan of the solar panel. And it's cost benefit process. So this is an example we consider in this kind of community, how to install the solar panel facilities at the level of the community and also in each buildings. And this one, I think, is useful for consider the electricity facility planning in the level of the city. And also, we also have another research focus on how to consider the total potential of the distributed photovoltaic in China. So we analyzed the whole China, the solar irradiance specification in China. You can see the high its altitude is different, so the irradiance is different. So this one is for the average solar power capacities in China, but based on the building road and the strongness of the solar irradiance. So this is we consider where is the shelter, also consider install the PV module, and mostly we focus on the rooftop of the residential areas in the building. And so this one we consider number of the urban household and simulate the possible the amount of the energy consumption in the residential areas. So I think it's almost my time. So this is like a summary of this kind of presentation. I presented my research recently. I have done for the smart house. This focus on the energy consumptions, but it's for the urban planning design. So first step, we visualize the building form based on the planning regulation for considering how to locate the maximum solar panel in the rooftop. And also, we consider how to install the solar panel in the roof and the building envelope built based on the climate conditions. They also consider the building design itself and also consider the roof design. And then we consider energy consumption based on house behavior. And we try to use all this research result for energy management at the level of the community and at the level of the cities. And all this work is supported by several GSPs projects. That means the Chinese government's research project. And anyway, we still try to cooperate with the researchers in Indonesia for continue this kind of research. And as I think in the beginning of this session, Dr. Purdy also introduced some of my publishing. I adding a book series with fingers, and also adding a journal for SPST community. And actually, this book, Green City Planning and Practice in Asian Cities, I got a lot of help of Dr. Pudris. He make the editorial work a lot for this book. I'd like to say thank you, Dr. Pudris. And
Welcome,
this
Shen.
book, actually, I under the help of the Dr. Rifai. He also do a lot of editorial work for me. And also, I'd like to say thank you, Dr. Rifai. And so I think your Vice Rector Alma and your Dean Andy will like to cooperate with SPST community for adding the International Review for Special Planning as a sustainable building. So I also like to show my appreciation to all the faculty members and looking forward to future cooperations. Thank you very much.
Thank you so much, Professor Sun. It's such a lovely and wonderful presentation. Actually, we've got only 1 minute for question and answer, and here I have two questions about your presentation. So you present so many research. I think it's so many research about the smart city between the say from the house level, community level, and the city level. So the question is how in Japanese context, how to achieve the smart city in the Japanese in Japan, and also for currently, what is the progress in Japan for the smart city project? Uh, Whether the smart city in Japan is how many percent of city in Japan could be a smart city, something like that. Please, Professor Sun.
Okay, the roadmap of the smart city project in Japan is more like I think this slide can explain the roadmap of the smart city in Japan, smart city construction. And the anyway, this is from the urban development, and they like to construct more smart infrastructures in the cities, and they try to use the big data to provide the smart services, and then to how to say, they will create more new smarter lifestyle and new cultures. I think the roadmap, the total constellation of the Japan. And from the 2015, in Japan, they totally considered of the, I don't understand how to say in dollars, but it's mean they consider almost 800 billions Japanese yen. No billion. I don't understand. The progress, the 70,000 billions market the skill in smart city in Japan only. And I think they consider the market is the third largest market in the world. And they have built several model cities like Kashiwanaha, the campus of the Tokyo University, in the town of the Kashiwa town. They also have the new model areas in Toyota and also in Yokohama and Kitakyushu. I think when people stay in Japan, you visit the Kashiwa town and the Toyota city, right? So I think that there's some kind of the model areas they like to improve the smart house. And I think recently the mobile focus on the smart energy management system. Then the 10 years ago, more than 10, probably 15 years ago, they have a subsidy system to support the people to install the solar panel. And that policy already finished because they only support 10 years. Now, Japanese people know that that kind of the government policy very well. So I think that HAMS is quite popular now. And also Japanese government from the 2018, they like to, they have a standard to make all the new buildings as zero energy buildings. So there's a big project in Japan. I think there are a lot of things, but most of the cities now, they use the HAM system, very popular now.
Okay. Okay, thank you so much. So about the answer, so I think it's a huge how to say project in Japan, considering a huge amount of money and funding. And in your consideration, how to say, in Japan, when we make a smart city want to be achieved, is it come from the developers or come from the government first? So is it the policy first or how to say, and the developer or company, something like that?
It's a very complicated questions. I think in Japan, it's my understanding. I think because I know the government officers, I think usually they will start some new projects with the funding of government. So I think it's my understanding that the government will launch the new project first day and invite the company, the big company, cooperate together to developed some new urban districts. So usually you can understand that there's when you study in Japan, you know that there are many projects supported by Japanese government, some kind of like full city project and environment-friendly projects and smart city project. There also such like the ecological projects. So that kind of project is actually supported, partially supported by governments, but the government will organize all the big companies to cooperate each other for the new construction, for the urban development. So that means the cooperation between government and urban developers and industry.
Yeah, that's interesting. I think maybe Indonesian government can adopt that kind of how to say method to make a successful smart city. So your answer it considered can be how to say the answer for the second question, where the panelists ask about what is the consideration for the government to make a successful smart city in terms of policy. So, so maybe government will make a policy first and invite the developers. So it, let's say half funding, something like that.
But half our funding is not so available because the Japanese government, they only make subsidy. I mean, the funding for the new technology part.
I see.
So, for example, the urban development, the cost is covered by the developers and industries, but the new part, the new technology part, will supported by government. That's the way Japanese government do.
Okay, thank you so much, Professor Shen. I would like to give you a big applause for your presentation. Thank you so much. It is our honor you join our conference, and I hope our next conference you can be invited again as a keynote speaker. Thank you so much, Professor Shen.
Thank you very much, and I'm also looking forward to see you in Japan. And your lectures and your team in Japan, in Kanazawa.
Yes, we will look forward for our cooperation with you, with your laboratory, your university, and also the journal itself. Thank you so much.
Thank you very much for the invitation.
So, thank you, ladies and gentlemen, for stay tuned in our keynote session 3. So we would like to have